Hi, this is the second short tutorial about environment diagrams, and I hope you like it. I'll present some examples of local and global state, and I hope that it will be useful. My name is Jalal Maleki, and I work at the Department of Computer and Information Science, Linköping University, and I teach programming concepts to engineering students. Currently we use Scheme for programming. Look at this particular state of affairs, which is an environment diagram, and I want to show you how such a diagram is created. What we see here is a variable called state in the global environment. It has a value false. And then we have some switches, two switches that could change this particular state, and switch 1 and switch 2. And then we have another switch 3, which has its own state, and another switch called switch 4, which also has its own state. So let's see how using these things, first of all, how this is created, and then how using this these switches affects the state of the computation. Here are the statements or expressions that have created some of the objects you saw, or actually all of the objects you saw. And first of all, we create a state by creating binding for the name state. And the next thing is we create two switches, switch 1 and switch 2. Both of them as procedures that change the state to something which is somehow the negation of the existing state. So if the state is false for the time being, calling switch 1 or switch 2 will change it to true, and vice versa. And consequently, we define two more switches, switch 3, switch 4, each of which has its own state and does almost the same, almost the same thing as those earlier switches. They changed the state to not state. Initially, we have this situation in which the state is defined as false, and then we'll follow the evaluation of the Lisp code or scheme code you saw just now. So the first thing we do is to define a switch called switch 1. Define, first of all, computes the value of the argument which is going to be bound to switch 1, and that is a procedure. It's a lambda expression which gives us a procedure, as we have discussed before, and then we bind it to switch 1. So this is how the switch 1 is created. Switch 2 is created similarly, and then we have a look at how switch 3 is going to be created. So define wants to bind switch 3 to something. What is that something which this blue statement represents? It is a let syntax, which is essentially a lambda expression. Let's expand it to what it is, like so. And there you see that this let is converted to an expression which has two parts, a procedure and an argument. The procedure and the argument. So what we have to do is to make sure that this procedure is computed first. Okay, I see that it's a procedure. Scheme hasn't seen it yet. Scheme has to evaluate this blue thing in order to know what it is. And then once it has computed this, then and realized it's a procedure, then it can apply it to this argument. So, that took a long time. So the blue statement is actually evaluated and we get a procedure. because it's a lambda expression. The body of the procedure and the parameters are stored somewhere, pointed to by this procedural object you see lower down on the page. And then we also create a pointer to the environment in which this procedure was created. So now we know what this blue statement results into. The next thing we do is to evaluate this little truth value, the false value, represented by hash sign and F. And that gives us the falsehood value. So now that we have all we need in order to evaluate this original blue statement you see on the screen, then we do the job by applying the procedure, which is marked with blue color, to the argument, which is the value false. And as we know, a new frame is created. In this frame, we bind the parameter of the procedure to the argument, which is false. Then we make sure that is the current environment, and in this current environment, we evaluate the body of the procedure we are evaluating. And the body says, I am a lambda expression. And we know what lambda expressions do. They create procedures. So a procedure is created. Once we create that procedure, that is the value that we get out of this original let structure. Okay, so this procedure you see down there is the thing that switch 3 is going to be bound to. So that's what we do. And as you saw, at the same time, the current environment was reset to the previous value, and that is correct. Shall we look at that again? We were there, we created a procedure, and now we name the procedure switch 3. Now we can go on, define another switch, switch 4, in the same way. We don't need to cover the details there. So we are at a point which looks like the original picture I showed to you. We know how these things were created. They were created by the expressions we saw earlier. What we do in the coming slides is that we turn these switches, press these switches in particular. You could call it turn it on or turn it off, whatever, but we call them. These are procedures, we call them. We start with switch 1, we call it. It's the procedure, and just like any procedure call, applying it means that we have to create a new frame in which its parameters, in this case nothing, are bound to arguments, in this case nothing, and then this becomes the current environment in which we will be working, and the work we'll do would be applying the body of this procedure, which says set state to not state. And that's what we do. We follow the frame sequence from the current environment, find state, and set it to not state. And this is what happens. State changed from F to T. Current environment was reset to what it was before, and this is how the world looks like. So let's do the same thing. Switch 2. Apply switch 2. What happens? A new environment is created, and that body is executed, and that true value we got there is removed, and it's replaced with F, for value false. So let's go on and call switch 3, see how that behaves. It has no parameters just like before, so we get a box, empty. New environment becomes that, points to that particular box, and there we evaluate the body of this procedure, which says set state to not state, and that's what we do. Okay? And the same thing with switch 4. So we start evaluating switch 4. We create an environment, and then that causes the state to change to state true. That's it. Well, one more thing. You see, here there are a lot of things, objects, hanging in the diagram, and nobody is anymore interested in what these objects are. This is usually indicated by objects to which nobody is pointing, or objects that have no names, in other words. These are in principle garbage that will be collected. So after a while you can imagine that the state of the computation is like this, that the things which were garbage are removed. That's it. Thank you for listening. I hope you find this tutorial useful.